Hey students, this is lesson 522. In this lesson, we're going to learn how to create geometric models to multiply binomials. So take a look at this rectangle here. It says write two expressions, one for the length, one for the width. Let's call this dimension right here the length. And if you look closely at that, we have a from there to there, and then an extra 2 added on. So that length would be a plus 2. And the width is the other dimension, and from there to there is a, and then from there to there is another 3, so that would be a plus 3. And part B says use your expressions to write an expression for the area. Well, the area is just length times width, so we just need to do our length times our width, and I'm going to use parentheses to help me do that. That would be a plus 2 times quantity a plus 3, like that. Then it says use the diagram to expand your expression for the area of the large rectangle. That is, write the area of the large rectangle without using parentheses. So another way to get the area, so the area is this whole thing right here, right? So another way to look at that area is in separate parts. So I have this area right here, which is a square. Then I have a rectangle right here, that area. Another little rectangle there, another little rectangle there. So as you can see, what I need to do is add up those 4 parts to get the total area. So what I'm going to do is write an expression for each of those parts using the length and width of each of those parts. So this length right here is a from there to there, and the width is a from there to there. So that expression for that area is a squared. This area right here, the length is 2, the width is a, so that area is 2a. Down on the bottom here, the length here is a, the width right there is 3, so 3 times a is length times width. And over here, this little part that's left over, the length right there is 2, and the width right there is 3. 2 times 3 is 6. So to get an expression for the entire area without parentheses, multiplying a plus 2 times quantity a plus 3, we get these 4 parts, a squared plus 2a plus 3a plus 6. And then you might notice that these two are like terms, so we can add those together, combine those, so we get a squared plus 5a plus 6. All right, let's look at another problem like that. Actually, let's go to the next page. If you want to try one on your own, go ahead and do number 2. But number 3 here, we want to, and this is on your next page, page 7. But it says draw a rectangle diagram to model the product, and then use the diagram to help expand the expression. So that means we want to write it without parentheses. So I'm going to draw this diagram. So I have w plus 2 squared, which means w plus 2 times the quantity w plus 2. So if I think of this square right here as w by w, then w plus 2 would just be adding 2 onto that, and it doesn't really matter what I think of as 2, but so we're going to add 2 to the length and add 2 to the width. And when I do that, I get a new rectangle that's this big. I'm going to split that little part there also. So now I'm going to expand the expression. That means I'm going to multiply it out, and I'm going to use the rectangle model. W times w is w squared. That's this part here. 2 times w, this length right here would be w, is 2w. This length right here is also w, so I'm going to multiply w times 2 to get that area of that rectangle. And then this little square you can see is 2 by 2. And 2 times 2 is 4. So now I'm going to add these together. My w squared And then I have 2w and 2w, those are like terms, and I want to add those two together, so that's 4w. And then the little piece in the corner is 4 more that I need to add on. So this expression right here is equivalent to this expression, and we can see that by the rectangular model there. All right, let's do one more here together. Number 4. It says a certain rectangle has an area of y squared plus 6y plus 3y plus 14. Draw a rectangle diagram to represent that. And you can see by this expression, since there's 4 terms, we're going to have 4 parts. So some rectangle, and I'll just draw it out 4 parts like that. And one of these parts is a square. It's a y by y. So even though that doesn't look really like a square, we'll think of that as a square. So this part right here is the y squared. And then we have one part that's 6 times y. Well, this rectangle here, this length down here would be y also, since it matches up with this one right here. So that's y. So we can think of this as 3. So that we get 3 times y for that area, multiplying that length times that width. Then up here, we also need 6y for an area. We'll put that here, and we know that this length right there is y. So that means this width must be 6 here. So 6 times y, and then there's only one part left, that's 18. And that makes sense because this is 3. That length right there is 3. That's 3. And then this length right there is 6. And 3 times 6 is 18. Okay. So that's the rectangular model that can model that. And then part B says, use your diagram to help you rewrite the area as an expression. Product of 2 binomials. And you can see that right here. Those two, this total length, which is y, that much is y, and this part is 6, so y plus 6. And then the width is, from there to there is y, and then from there to there is 3 more, so y plus 3. So those are the 2 binomials that multiplied together give us this expression. All right, if you want to try a couple more, go ahead and try either number 5 there or finish up number 3, and we'll talk about this next time we meet in class.